Friend, enemy, or frenemy? How do Indians view the rise of China and its implications for India's rise? Join the conversation on this important topic by taking the China Challenge survey. The survey has been put together by researchers at the Takshashila Institution. Answer our 10 simple questions and let your voice be heard in shaping India's policy towards China. For more details, log on to www.takshashila.org.in or you can click on the link and take the survey in the show notes. Welcome to All Things Policy, a daily podcast by the Takshashila Institution. We are a bunch of policy nerds based in Bengaluru, and we like bringing fresh perspectives to Indian affairs and Indian perspectives to global affairs. So grab a cup of coffee, sit back, and join us for today's chat.
Hello everyone, this is Avinash Shet and I have with me retired Air Marshal TD Joseph. He is a former fighter pilot and flying instructor of Indian Air Force who have served the nation for 39 years. Thank you for joining me in this episode.
Hello Avinash, hello dear friends.
In this episode of All Things Policy, we are going to discuss India's aspiration to have an indigenous jet engine. So, Air Marshal, we have been developing our own jet engine from last 3 decades. Please tell us why it is so critical to have our own jet engine. What are the concerns that drive us to build an indigenous jet engine?
That's a good question, Avinash. See, you have read about the orders that have been placed for manufacturing LCAs Mark 1 and Mark 1A. In fact, it's near almost 200 aircraft which are meant to be manufactured by Hindustan Aeronautics Limited and given to the Indian Air Force. All these require engines. We have so far contracted for over 150 aero engines from GE General Electric's United States, who manufacture the F404 as well as F414 fighter jet engines. In essence, what has happened is we have designed a beautiful aircraft, the Tejas light combat aircraft. We have the indigenous aircraft, self-built aircraft, but no indigenous engine to power it. Therefore, our dependence on foreign companies and foreign nations have come up, which is susceptible to geopolitics. And also, when crisis hits other countries, priorities would change. For example, after post-1998, the United States sanctioned supply of critical technologies for development of LCA aircraft itself, leave alone the engine. And also, even after the sanctions were lifted and we started receiving the critical technologies, which went a long way in building our aircraft, even recently, after contracting these engines from General Electric, there have been delays in supplies because they've had to prioritize supplying their own allies, their own countries at the cost of meeting the time frames of Indian Air Forces and India's requirements. That's why it is critical that if we have our own engine, successful engine, we don't have to depend on anybody else. We may have to depend on the other players for certain critical components, which you can always buy. But the whole engine manufacturing as a process, as a capability, is essential and is critical for national security.
As you mentioned about the geopolitics of it, right, and why it is important to have our own indigenous jet engine. So, where did it all started? I mean, why did you even think of having it? GTRE started at around 1959.
1959 it was established in Kanpur.
What was the reason, for its establishment? What we were trying to achieve during those times?
Oh yes, actually, if you look at it, at the time of independence, India had a fairly robust aircraft manufacturing industry. Okay, yes, we are not ventured into manufacturing of jet engines that time because that was a new technology as it is. And initially, we were dependent upon the foreign suppliers for our aircraft as well as engines. HAL, in fact, was successful in developing and manufacturing the Hindustan trainer, the basic trainer which the Indian Air Force used for many, many years. Okay. Realizing the criticality of and the importance of having own jet engine development capabilities, GTRE was set up in 1959. It moved to Bangalore in 1961. Okay, and they have tried their hand at developing various types of engines, some of it successful. But the major technology of jet engine manufacturing is what we are yet to master.
So I have been reading about the first fighter aircraft we had and how we had trouble with the engines to realize the full functionality or the power of the aircraft, which is HF-24.
You're talking about HF-24, the Maruth.
Yes, yes.
A beautifully designed aircraft by Kurt Tang, who was the designer of the aircraft with his team. But as you mentioned, it did not live up to its promises. It could not live up to its promises, actually, because of lack of suitable engine for it. We did not have the technology. Okay. In fact, it is interesting to see how quickly we developed the HF-24, even though decisions were taken in the mid-50s to have our own supersonic fighter aircraft, which is capable of carrying out different types of missions. HAL began the work in 1956, actually. The first flight was done in a short span of 5 years, which is very creditable. On 17 June 1961, the HF-24 took to the air. Okay. And it was introduced into the Air Force in April 1967. In fact, on 1st April 1967, those days the Air Force Day used to be on 1st April. Okay. We built 147 of these, including 18 trainers, which are two-seaters actually. Initially, these aircraft were powered by the NATS engine, the Orpheus 703 turbojet engine. It did not have an afterburning capability, which provides that much required thrust for during combat missions, for a faster takeoff, faster acceleration, faster maneuvering, faster climb, and all those things. It's interesting to note, Rolls-Royce had approached Indian government to assist in manufacturing or redeveloping the Orpheus engine with an afterburner. All that required was probably some funding from the Indian government. For whatever reasons, Indian government at that time refused this offer. So attempts were made to get these engines for the HF-24 Maruth from the then Soviet Union as well as from Egypt. But both attempts did not succeed.
But GTRE was established during that time, right? So did GTRE played any role or took up, developing those engines or enhancing those engines?
Yeah, in fact, what GTRE had been working on the Orpheus engine. They tried to improve the Orpheus engine themselves, having refused the offer of Rolls-Royce. They tried to convert it to an afterburning reheated engine to provide the necessary thrust. Unfortunately, in one of the trials using this engine, one of our leading test pilots, Group Captain Surendran Das, died. So finally, that program had to be shelved. So the end result was that the HF-24 Maruth could never go supersonic. It could never reach the full potential of a well-designed, beautiful platform that it was.
Okay. So with this, backstory, when did we even thought of having a Kaveri engine? How did these new era of developing Kaveri engines started?
Oh yes, when we decided to go in for development of LCA, the Tejas, we needed to have an engine for it.
So that we don't do the past mistake of not having an engine for
Absolutely.
HF.
Yeah. So we have an establishment which was set up for precisely this reason, and they have been doing research and development of jet engines. So it was felt that we must have our own jet engine for our indigenous fighter aircraft. So that's why in the 1980s, GTRE was authorized to research and design and develop the Kaveri engine. In fact, in 1986, the authorization was given, and a full-scale development of the engine was authorized in April 89.
Interesting. Yeah. So now this whole development has taken 3 decades. So what we have achieved in this and where we are right now?
Okay, let me go back to the times after it was authorized to develop this. Okay, they carried out a first run of the engine in 1996. That I think they carried out the core run. That's Kabini. The Kabini was tested out in 1996, and it had to be followed up with a full engine. You fit the compressors, compressor blades, you fit the turbine, low pressure turbine, high pressure turbine blades, have the disc ready. So all that takes time, it takes experience, it takes funds. Okay. What has happened is, unfortunately, the program failed to keep up with the promised timelines. If the aircraft design, let's say, was to be completed in about 12 or 13 years, the engine should have been ready by then to be fitted on the aircraft and to be tested after having successfully conducted the requisite tests both on the ground and in the air for high performance. But that time frames could not be met. Okay.
Okay. So I mean, I can totally see in India, the journey of Kaveri engine, right? If we really try to compare it with the very selective countries, we have only 4 countries who have the capability of developing these jet engine. So did they also face the same problem? What kind of capacity we are seeing? Because most of them are developed countries, right?
Yeah, I would like to tell you it's not 4, it's actually 5 countries.
Okay.
Because we read Western literature, most of us limit our knowledge, tend to look at only the Western countries' manufacturing. Okay, so we have in the United States of America, we have the General Electric as well as Pratt & Whitney. Then we have the Snecma Safran of France, the Rolls-Royce of UK, and then we have Russia's 2 companies, Aviadugetel and NPO Saturn. So these are the companies. So essentially it's 4, not 5. But if you look at the time frames, I've read somewhere that Snecma Safran, who manufactures, for example, the engine for Rafale. Okay. They've had something like 50 years of experience by then. Even then, the program had cost overruns, time overruns, and it took them 13 years to develop that engine with 50 years of experience. We must also understand that they have had and they have sufficient amount of funds to do the research and development. They have the capacity to accept failures, to accept risks, okay, and come out of it. The global, do you know what is the cost of manufacturing, designing and developing a new engine?
No.
It'll be interesting. Global standards are actually close to $2 billion.
Okay.
As against that, as of 2009, I think DRDO or India has spent only 240 million, or nearly 1/8 of the cost. That is apparently the global standard for a modern jet engine design and development.
Okay, so then I think it would be not fair to compare ourselves with the countries or the companies who have already developed. Do you?
No, it is fair to compare, because considering that you have a research establishment for now nearly 6 decades, 6 to 7 decades of its existence, should have developed certain expertise and capability in developing a new engine. But even then, the critical parts of the challenges and complexities which are involved with jet engine manufacturing.
Yeah, I mean, so I would like to understand, it takes such good time to develop, and so much of funding to be put in. So what kind of complexities we're looking at?
Well, you're asking the wrong person. You're asking the end user, the pilot, about this question, which is highly technical in nature. Okay, a qualified engineer would be the right person to answer this question. But let me rack my brains about my superficial knowledge about engines, about jet engines and their capabilities. Okay, firstly, look at the technical complexity of an engine. What all pressures and temperatures it has to withstand. Imagine you require something powerful enough to generate enough power to be able to accelerate an aircraft from 0 kilometer speed to something like 200-300 kilometer speed in a matter of about 10 to 15 seconds, which is the time frame that it will take to lift that aircraft from the ground and thereafter accelerate it to supersonic speeds which supersonic speed, by the way, at sea level is 1,225 kilometers per hour. So when an aeroplane is flying at 1,225 kilometers per hour, you can imagine the pressure that is coming and facing or impacting the front end of these compressor blades. These blades, which are rotating anywhere between 6,000 to 9,000 plus RPM, revolutions per minute. Okay, so they are undergoing forces of rotary motion as well as forward motion. All right, and subsequently, I'm sure you know, being an engineer, you know the science of behind the thermal efficiency and things like that. The turbine blades are impacted to temperatures of 1,400 to 1,600 degrees Celsius, which means you need to have metals which are capable of withstanding those temperatures. So at these temperatures, most metals suffer from creep failure, metal fatigue, and therefore leading to material failure, and also corrosion failure due to heat. These are some of the simplified major uh, failures that can happen at these temperatures, which means we need critical materials to withstand it. That is where superalloys come in. So what happens in the superalloys? They're basically, actually, modern turbine blades are based on nickel, okay, with chromium, cobalt, and rhenium added to make an alloy, okay, which can withstand these kind of temperatures. Plus, there are other technologies, manufacturing technologies like the single crystal plate manufacturing ability, okay, different cooling methods to cool the compressor blades and the rod compressor blade, turbine blades actually, which are facing the heat. Okay. So this is what happens. So that's technical complexity in its basic nature, in a layman's term that I'm explaining. Do we have that ability to manufacture such plates? That's a challenge. We are not at the forefront of such critical technologies, which is what foreign manufacturers will deny to you because they want to control critical technologies. These are strategic capabilities. So they will not give that. And we lack, as we know it very well, we lack the experience of design and development. We've also, as I mentioned earlier, the funds required, if others spend about $2 billion and we are spending only a few hundred millions, then you cannot expect success straight away. So actually what's happening is, because we did not develop engines earlier, the dependence on foreign suppliers continued to increase, which in turn leads to decrease in autonomy.
Coming back to the Kaveri engine itself, now, so it has only achieved till now 2 out of its 6 milestones, right? I mean, we talk about its, they have able to complete core engine demonstration, full engine demonstration, and high altitude test, preliminary flight rating test, type test, and flying test bed is something which is yet to be done, I guess, right?
The flying test bed tests have been undertaken on the IL-76 in Russia on various occasions. Yes, the initial tests in early 2000 and all did not meet the standard, so they had to repeat those tests. But as I understand it, the flying test bed, high altitude test in a flying test bed, was relatively successful in the recent past, apparently, and to a fair degree. I wouldn't say it is a complete success, but this is as I understand it, would have been in the dry regime. And not in the afterburner regime, which is yet to be tested out. Okay. And then, of course, subsequent to the flight test bed success and meeting all parameters, only would they graduate onto fitting it on the desired aircraft, fighter aircraft, testing it on the ground, and subsequently carrying out the subsequent series of tests required before it's sent to air.
So talking about the test, we know that high altitude test, which is being done on Kaveri and even the flying test bed, these kind of testing facilities is something we don't have it in India, right? So what's your view onto it? I mean, what should be the future looks like?
See, at the moment, as long as we have somebody who's helping us out with these test facilities, it is good. We can survive that. But if we want to be a self-respecting designer and manufacturer of any system, especially things to do with critical technologies affecting national security, it is important that we have our own test facilities. We have to fund it. We have to develop it. Or we have to buy it. As long as we have friends who are willing to help us, utilize that time to develop our own. We have to be self-sufficient in this eventually.
That's interesting. So to become self-sufficient, how do we see other part of ecosystem helping us in it? Where we talk about HAL, who has been manufacturing engines for quite some time, used for helicopters and
You're talking about the Shakti engine.
correct.
Okay, the Shakti engine is actually fitted on the ALH Advanced Light Helicopter of the Indian Air Force, which is manufactured by HAL, and also for the subsequent development of light combat helicopter, as well as the light utility helicopter, LCH and LUH. Actually, Shakti engine is a joint venture between Safran and HAL for this aeroplane. I understand that actually HAL has manufactured for almost more than 500 of these engines.
So they have the experience to build an engine once GTRE is done developing, a fit engine for the upcoming fighter aircrafts.
Absolutely. The GTRE's role is in design and development. And subsequently, they will hand over the design, the technology aspects, the drawings and everything to whoever decides to whoever is given the responsibility of manufacturing these engines.
It could also
be a HAL, could be the private sector, private players who have the funds and who have the capability and who will need a certain amount of hand holding in getting the entire industrial setup going. And I believe certain private players like Godrej and all are involved in the process of manufacturing components of Kaveri at least.
So these days, there are many startups, at least a couple of startups who have come up and have built working jet engines at a very small capacity, right? And do you think these companies can scale up to a level where they can achieve or build an engine which can be put in a commercial aircraft or fighter aircraft?
Can they? They can, provided they become much bigger players, provided they have the ability to invest in the manufacturing machines, assembly lines required to manufacture various components, subcomponents, main components. And you must remember 3 critical aspects: casting, forging, and machining of engine blades and other components. That has to be of the highest precision required, highest quality required. The metallurgy, the quality of the metallurgy. These things are very, very difficult to manufacture, master. It may not be easy for startups to master these. Yes, they will be able to provide, in my opinion, they will be able to provide components, smaller components, which goes into the overall engine. That's where they will begin. But for manufacturing engines, you require big players. Just remember, China for so many years has been attempting to manufacture a jet engine. Have they succeeded?
No.
They have not, with all the funds and with all the freedom provided by the state to them. So it is not an easy task, but it is not impossible. It is achievable.
Interesting. So, now we are almost at the end of the podcast, and I would like to understand how the future look like if, GTRE is successful building an indigenous jet engine in, like, let's say next 5 to 10 years. What geopolitical changes, what kind of changes we are looking in terms of geopolitics?
We don't have to look at any changes in geopolitics. If DRDO or GTRE succeeds in designing and developing the engine, and I'm sure they will, we become self-sufficient. Our dependency on anybody else outside will reduce, obviously, which means we will be immune from the pressures of geopolitics. Friends could change. You may not have allies. You may have to stand on your own. If that happens, we need our own technology. We need our own capabilities. That is the most important aspect. We can stand on our own feet. Just to put in perspective, let's say we have been talking of how our strength of fighter squadrons have come down. Okay, if we were to go up to the 42 squadron fleet, we need something like, including reserves, we will need to the tune of 900 combat aircraft for the Indian Air Force. At the moment, we are about 550 or so. Okay, which means we'll need engines for, even if we take half of it, 450 to 500 aircraft engines we will have. Ideally, we should have for all of them, our own engines. It's a huge, huge potential, huge market out there for not only the public sector, but also for the private sector. But to be there, we have to invest adequately in R&D. We have to provide the right environment. And you young, talented engineers like you would need to be pulled towards the research facilities.
Yeah, I totally agree with you. Intensity of research, providing enough funding, and finding the right talent is something which we'll need to look forward for to build this kind of ecosystem, to build this, to go forward with, having our own indigenous jet engine.
Certainly. Add to that, conducive environment for carrying out research effectively. And we as a nation should be willing to accept failures. In research, there would be a series of failures. We should be able to accept that, accept the loss, monetary loss that would happen through that. But in the end, there will be success. Without failure, we cannot achieve success in such critical technologies. The future is bright if our engineers are key players in foreign companies in manufacturing this. They can be the key players in India too. We have brilliant youngsters, brilliant institutions, IITs, IISCs, and other engineering colleges who will provide us the right talent. Let us, the government, as a country, provide the right environment and funding and infrastructure.
Thank you, Air Marshal, for joining me in this conversation. And let us hope that we become a self-sufficient in jet engine manufacturing.
Thank you, Avinash. The future is bright. Let's dream on.
If you liked our show, dive into Takshashila's research on technology, strategy, and economic affairs. Check us out at our Twitter handle @TakshashilaINST or our website takshashila.org.in.